this video lesson, we shall learn 5 different methods of solving quadratic equations. These 5 methods are direct square root, factorization, graphing, the quadratic formula, and completing the square. Then we shall show you a quick calculator method to confirm your solutions independently. Before we dive into the main lesson, we have 3 key points to ensure we all start on the same footing. First, the standard form of a quadratic equation. ax squared plus bx plus c is equal to 0. The terms on the left side are in order of decreasing powers of x. A times x to power 2 all squared, b times x to power 1, and c times x to power 0. X to power 0 or any number to power 0 is 1, so c times x to power 0 is just c. In a quadratic equation, the highest power of x is 2. So this is a standard form of a quadratic equation. A, b, and c are known as coefficients, and they should all be integers. The right side of the equation should always be 0 in the standard form. Everything else to the left of the equal sign. Here are a few examples. In this equation, a is equal to 1, b equals 3, and c is equal to -4. Be very careful not to miss the negative sign before a coefficient or the invisible one in a standalone term of x. Another equation. What are the coefficients here? A is equal to 2, b is equal to -1, and c is equal to -3. Your turn now. List the coefficients in this next one. Feel free to pause the video if need be. A is equal to 4, b is equal to 0, and c is equal to -11. When a coefficient is 0, that term disappears. There is no need to write 0x, for example, in this case. One more example. A is equal to -3, b is equal to 1, and c is equal to 0. In the standard form, a is called the leading coefficient, and it should never be equal to 0, because without the x squared term, we have no quadratic equation. In all our methods, we shall first present the equation in the standard form. Our second key point is about the type of roots or solutions we can expect from any given equation. We shall use sketch graphs to explain the 3 possible scenarios. Case 1. Here is a sketch graph, and this is a possible equation that produces the xy pairs for any point on this graph. For any point along the x-axis, the value of x is 0. So we can write our equation, but put y as 0. When we solve this quadratic equation with 0 on the right-hand side, we are expected to get the values of x corresponding to the intersection of the curve and the x-axis. In this case, there are 2 points, 2 roots. If we plot a proper graph, we should be able to easily read off these roots on the real number line, the x-axis. The roots are the solution to this quadratic equation. We shall be doing this practically in the graphing method coming up later in this lesson. But without sketching the graph, which can be laborious and time-consuming, there is a very quick way to determine whether an equation has 2 roots, 1 root, or no real roots. We can use the discriminant, a big word, but with a simple direct formula. The discriminant is calculated using the coefficients. It is equal to b squared minus 4ac. Let's calculate the discriminant for this equation by just plugging in the coefficients. A is equal to 2, b is equal to -7, and c is equal to 3. When we plug them in and simplify, we get 25. However, it's not the number that we need. We need to know whether the discriminant is equal to 0 or whether it is positive or negative. In this particular equation, the discriminant is positive. A positive discriminant means that the equation has 2 distinct real roots along the x-axis. Let's look at case 2. Here is another quadratic curve and the possible equation from which it is plotted. And this is the x-axis where y is equal to 0. The curve and the x-axis intersect at only one point. This one here. It is the only root, the only solution to this equation. Let's see how quickly we could have predicted this one root using the discriminant. Plug in the coefficients, these ones, and simplify. The discriminant is 0. Whenever you get 0 discriminant, the equation has only one real root, one point of intersection on the x-axis. Case 3. Here is another graph, and this is a possible equation for it. In this case, however, the curve is entirely above the x-axis. The curve has no point along the x-axis. If we try to solve this equation, we get no real roots, no solutions. Note, the roots to this equation are complex numbers which are beyond the scope of most O-level math courses. So for our purposes, there are no roots because the curve does not cross the x-axis at all. This should be much faster to predict with the discriminant. Plugging in the coefficients and simplifying, we get -3 as the discriminant, which is a number less than 0. A negative discriminant means that we do not have any real roots. In summary, it's easy to predict the type and number of solutions you can expect from a given equation without sketching its graph. It takes only seconds to determine the discriminant, just a quick magical test. Here is a third key point. Square roots come in pairs. Let's demonstrate this quickly. What is the value of 3 squared? We know it is 3 times 3, which is the same as 9. How about -3 squared, or -3 times -3? It is also equal to 9. If you use your calculator to square a negative number, enclose the number together with the negative sign inside brackets and then square. So now, what is the square root of 9? Both 3 and -3 are valid square roots of 9. We normally write this as plus or minus 3. Any positive number has 2 square roots, both equal in size, but one is positive and the other one is negative. Therefore, if x squared is equal to r, x should be equal to plus or minus root r, meaning x is equal to root r and x is equal to negative root r. Now on to the main lesson, the 5 methods of solving quadratic equations. Solving by square roots. X squared minus 81 is equal to 0. Start by adding 81 to both sides. So now we have x squared is equal to 81. Take square roots of both sides. So now we have x is equal to plus or minus the root of 81. Same as x is equal to plus or minus 9. So our two solutions are -9 and 9. X squared minus 12 is equal to 0. Add 12 to both sides. We have x squared is equal to 12. Take square roots. X is equal to plus or minus the root of 12. 12 is not a square number, but we can express it as 4 times 3. So the square root of 12 is the square root of 4 times the square root of 3, plus or minus. Square root of 4 is 2, and then we leave the square root of 3 in that manner. So our solution is -2 root 3 and 2 root 3. 2x squared minus 9 is equal to 0. We rewrite that as 2x squared is equal to 9, having added 9 to both sides. Dividing both sides by 2, we get 9 over 2. X squared is equal to 9 over 2. Take square roots. X is equal to plus or minus the root of 9 over 2 in brackets. Square root of 9 is 3, and square root of 2 is root 2. So our solution now is -3 over root 2 and 3 over root 2. There you have it. A very simple and straightforward method. However, have you noticed any limitations to this method? It can only be used when the middle term is missing. That is, when the coefficient b is equal to 0. Solving by factorization. 2x squared plus x is equal to 0. This equation has got only 2 terms on the left-hand side, so there is no constant term. X is a common factor to both terms. Factor out x, and we have x into brackets 2x plus 1 is equal to 0. The goal of this method is to get two distinct factors, each of which is a linear function of x, and their product is 0. When the product of two terms is 0, it means either one of them or both are 0. This is the logic behind our next step. Equate each of the factors to 0 one at a time and simplify. So first one, x is equal to 0. This needs no simplification. It is our first root, our first solution. 2x plus 1 is equal to 0. Subtract 1 from both sides. 2x is equal to negative 1. Divide by 2, and x is equal to negative 1/2. Our complete solution therefore is 0 and negative 1/2. X squared plus 11x plus 24 equals 0. Factoring the first term, x times x will produce x squared. We open two brackets and each starts with x. Now we need factors of 24, which should also add up to 11. We know they should both be positive. How do we know that? Because their product is a positive number and their sum is also positive. Both factors must be positive. Try 1 and 24, but their sum is not equal to 11. 2 and 12? No, they don't add up to 11. 3 and 8? Yes, that's a pair we need. So we put 3 and 8 and perform a quick test. X times 8 is 8x, then 3 times x is 3x. 8x plus 3x is 11x, exactly what we need. So now here are our two factors. X plus 3 times x plus 8 equals 0. Equate each to 0 and simplify. X plus 3 equals 0 means x is equal to negative 3. X plus 8 equals 0 means x is equal to negative 8. And that's our complete solution. 6 squared minus x minus 2 is equal to 0. In brackets, we write the factors of the first term. 2x and 3x would multiply out to 6x squared. Note that we do not consider x and 6x because 6 would still remain unfactorized. Let's now look for the factors of 2. And we know it is 1 and 2. But shall we add or subtract? We know one of the numbers must be negative and the other positive because their product is negative 2. If we had negative 1 and positive 2, we would have negative 1 times 3x and then 2x times 2. Negative 3x plus 4x is equal to 1x positive, which is not what we need. So we shall take positive 1 and negative 2 and perform a quick test. 2x times negative 2 is negative 4. 1 times 3x is positive 3x. Negative 4x plus 3x is negative 1x. So this is a pair of factors that we need. 2x plus 1 is equal to 0. Therefore, x is equal to negative 1/2. 3x minus 2 is equal to 0. Therefore, x is equal to 2/3. That's our complete solution. 9x squared minus 12x plus 4 is equal to 0. Each of the brackets should start with 3x, the factors of the first term. The factors of 4 are 2 and 2. But what is the sign in between? The only combination is that both must be negative so that their product is 4, positive, and their sum is a negative number, negative 12. That is 3x times negative 2 is equal to negative 6. 3x times this negative 2, another negative 6. Sum is negative 12. That is a pair of linear factors that we need. In this case, we end up with identical factors, 3x minus 2. This is a case of a perfect square because we could write this as 3x minus 2 squared. We only need to solve one of them. 3x minus 2 is equal to 0. Hence, x is equal to 2/3. And that is our only solution for this case. X squared minus 121 is equal to 0. We can solve this by direct square roots, the method we learnt above. But for learning purposes, we shall use factorization. This specific type of equation is commonly referred to as the difference of two squares. The first term is the square of x. The second term is the square of 11 with a negative sign between them. There is no middle term. Coefficient b is equal to 0. So the pair of brackets should start with x each, and then we put plus 11 in one of them and negative 11 in the other one. This is how we factorize the difference of two squares. Square root of the first term plus square root of the second term minus square root of the second term. Straightforward. Let's quickly test their sum. X times negative 11 plus x times positive 11. They cancel out, so there is no middle term. Our two brackets. The first one, x plus 11 is equal to 0, so x is negative 11. Then x minus 11 equals 0, x is equal to 11. And that's our solution. 9x squared minus 16 is equal to 0. The first term is a square of 3x. The second term is a square of 4 with a negative sign in between them. So this is another case of the difference of two squares. Two brackets with the square root of the first term. Then we add and subtract the square root of the second term. Plus 4 minus 4. Our two brackets. 3x plus 4 equals 0 means that x is equal to negative 4/3. 3x minus 4 equals 0 means x is equal to positive 4/3. Our solution set therefore negative 1 1/3 and 1 1/3. You should now be able to solve any quadratic equation that requires factorization. This method also has limitations because not all equations are factorizable. The next three methods can be used without limitations to solve any quadratic equation with real roots. Solving by graphing. X squared minus x minus 4 is equal to 0. To plot a graph, we need a table of values. Let's take advantage of the table function in our calculator. Press mode, select 7, table, key in 7. It asks for the equation of our function, that is the equation that will produce the values of y. Our equation is x squared minus x minus 4. So, alpha x squared minus alpha x minus 4. Press equals. Starting point. Let's start at x is equal to negative 4. Press equals. Let's end at x is equal to 5. Press 5. Press equals. Steps. Let's key in 1. In steps of 1. Equals. We get our table of values. We can scroll down to ensure we have y values above 0 and below 0. Because our graph needs to cross the x-axis. And yes, we have y values decreasing from 16 to negative 4, then increasing again. We have a good working range for our graph. Back to the top. Let's make a quick table and list out our points from the calculator. Negative 3, 8, negative 2, 2, negative 1, negative 2. Then we scroll down for the next values. 0, negative 4, 1, negative 4, 2, negative 2, 3, negative 2, and 4, 8. No need for very high y values, so we cut off our table at negative 3, 8 and 4, 8. So now here are our xy pairs, our points. Take the graph paper and mark out the scales with a suitable range of numbers to accommodate our points. Then plot each point. Negative 3, 8, negative 2 and 2, negative 1, negative 2, 0, negative 4, 1, negative 4, 2, negative 2, 3, 2, 4, 8. Once you plot, do a quick check to be sure the points generally hint to a parabolic curve. If not, double check with your table of values. Join the points with a smooth curve. Use a pencil so you can erase and correct any mistakes. Here is our finished graph. We are interested in the points where the curve intersects with the x-axis. And we shall read off these values, negative 1.6 and 2.6. And we have now fully solved our quadratic equation using the graphical method. Using the quadratic formula, 3x squared minus 4x minus 7 is equal to 0. The coefficients are 3, negative 4, and negative 7 respectively. And here is the quadratic formula. It may look intimidating at first, but trust me, with regular use, you should be able to remember and apply it with ease. Let's practice. We need to plug in our coefficients in the formula and then pick up our calculator. This is a fraction structure, so we start by pressing the fraction key, then we key in the numerator first. Minus b, which means minus brackets minus 4 brackets. It is good practice to wrap negative coefficients in brackets so the calculator will interpret them correctly. Our formula says plus or minus, but we can only use one at a time in the calculator. We start with the plus to get the first solution, then later we can use the minus to get the second solution. So press plus, then square root sign, brackets minus 4, close brackets and square, minus 4 times 3 times, brackets negative 7, close brackets. Press down arrow so that we can key in the denominator. 2 times 3. Press the right arrow so the cursor is at the end of the equation. Press equals, and we have our first solution. 7 over 3, or 2 1/3. To get our second solution, we do not need to key in the numbers again. We only need to change this sign from plus to minus. No other change is needed. Navigate with the arrow keys to take the cursor back to the position just left of the square root sign there. Press delete to get rid of the plus and key in minus. Navigate back to the end of the equation. Press equals, and that is our second solution, negative 1. So that's now our complete solution using the quadratic formula. Solving by completing the square. X squared minus 4x plus 1 is equal to 0. Subtract 1 from both sides, so we only have these two terms on the left side. We now need to add an appropriate third term here to the left side to make it a perfect square. But whatever we add to the left side, we must add the same to the right side to keep the equation balanced. The question is, what is this appropriate term? Here is what a perfect square looks like, in factor form and in expanded form. We need our left side of the equation to look like this expanded form. Then we can work backwards to the factorized form. The third term, which we need to add here, is a squared. That's what we need to add to both sides of our equation. Where does a come from? A comes from the middle term. In the middle term, the coefficient of x is 2a. In our case, the coefficient of x is negative 4, meaning 2a is equal to negative 4. That means our a is negative 2. So our third term is negative 2 brackets squared. And we add the same to the right-hand side. Now our left-hand side looks like this expanded form of the perfect square. We now need to write it in this form, the factor form, which is x plus a in brackets squared. Our a is negative 2, so we shall write x minus 2 brackets squared. The right-hand side is negative 2 brackets squared, which is 4 minus 1. so it gives us 3. We can now take square roots of both sides. The left-hand side we have x minus 2 is equal to plus or minus root 3. Add 2 to both sides and we have x is equal to 2 plus or minus root 3. And that's what gives us our two solutions. 2 minus root 3 and 2 plus root 3. Congratulations for making it this far. We are now sufficiently skilled and ready to tackle any quadratic challenge. Let's now put the icing on the cake. Here is a bonus method that uses the calculator to solve any quadratic equation in seconds, quite literally. The calculator has an inbuilt function for solving quadratic equations. Press Mode and choose menu item number 5, EQN for equation. So we press 5. Looking down the menu items, number 3 is ax squared plus bx plus c is equal to 0, which is the standard form of our quadratic equations. So we press 3 and the calculator will prompt you to key in 3 numbers, a, b, and c, which should be the 3 coefficients of our quadratic equation in standard form. Let's take an example. X squared plus 11x plus 24. The coefficients are 1, 11, and 24, respectively. Those are the numbers we key in to our calculator. 1, press equals, 11, press equals, and 24, press equals. Press equals again, and we get x1 is equal to negative 3. That should be our first solution. Press equals again, and you get our second solution, negative 8. That's our solution. If you press equals again, the calculator prompts for another set of coefficients. We can do another example. 6x squared minus x minus 2 is equal to 0. The coefficients are 6, negative 1, and negative 2 respectively. So we key those in. 6 equals negative 1 equals negative 2 equals. Press equals again, and we have x1 is equal to 2/3. Press equals, and we get our second solution, negative 1/2. So we have 2/3 and negative 1/2. 9x squared minus 12x plus 4 is equal to 0, and the coefficients are 9, negative 12, and 4. Key them in. 9 equals negative 12 equals, and 4 equals. Press the equal sign, and this time it is just x is equal to 2/3. No x1, no x2, meaning this is the only solution to our quadratic equation. Our solution is 2/3, a single value. This works like magic. It is a very useful method for confirming your answers in any of the methods earlier discussed. But since most exams require you to show full working, this method is not recognized for full marks. Moving forwards from here, you need to practice solving equations using any appropriate method from the 5 given. And now you have the power to double-check your solutions using your calculator, which gives you instant feedback. My best wishes in your practice. Which calculator do you have? Are you able to perform these operations on it? If not, comment below and tell us the model you use. Hopefully, someone with that model will come to your help. Watch the next video. Share with a friend. Subscribe to the channel and hit the notification bell icon. Thank you for watching.